Okay, ladies and gentlemen, before we get started, I wanted to show you a website. Since we are starting with human population growth, show you a website called the World Clock. As you can see, there's currently 7.26 billion people on the planet. And this clock kind of breaks it down. Here's our current world population. You can see it moving up ever so slowly, quasi-quickly. And then you can see below how many births have we had today, how many deaths have we had today. So our total growth, births this year, deaths this year, so our growth this year. Okay? And as we go through this PowerPoint, we'll kind of look at, and I'll tell you how many people we're adding per day, and you can see, which is 225,000 after you subtract out the deaths. And it looks like we're on par to hit that today, being at 235, and then we're going to take away 97,000 right now. By the time this day ends, we should be right around 225,000 people. So what I want to write down or make note of is this right here, 713, because I won't be able to, we don't want to keep track of all these numbers, just these last six. 713,000, and we'll say 870. So 713, 870. That's the population right now. 713, 870. 713, 870. What is it? Oh, it's 713, 870. 713, 870. All right, those are the last six numbers of the total population. So what are we going to cover right now? 6.1 and 6.2. How many people can the Earth support, and what factors influence the size of human population? Whoa, I just hit this thingy. Hold on a second. Sorry. All right. There we go. Click. Okay. How many people can the Earth support? If you look back at Earth's history, you can see it took 60,000 years, which is about how old our species, Homo sapiens, actually, how old it is when we fully became us. And it took us a billion years before, sorry, it took us a billion years, 60,000 years before we reached a billion people. All right? And then ever since then, it has been going, the population has been growing at an increasing rate. You can see the time in years that it takes to add our next billion has been going down. And so right now, it's actually slightly starting to go back up. See what, 13 years, 14 years, 13 years, 12 years, now it's back up to 13. And hopefully, via education of women in third world countries, we can get this number to be bigger and bigger. So our current growth rate is, this is 1.22% annually, and our 8th billion person should be added in 2025, excuse me, our 9 billionth person in 2043. Yeah, it's a lot of people, a whole bunch. Like I said, we had 225,000 people every single day to the planet. But this growth isn't evenly spread, and we'll talk more about this later. In developed countries, the growth rate is 0.1% per year, versus developing countries, it's 1.5% per year. All right, so it's a 15 times higher in developing countries over developed countries, which is crazy. And the question is then, how many people can we actually support? Especially since we've already impacted, as we are now, 7.2 billion, 83% of the land on the planet we've had a direct impact on. So how many more can we add and keep without having a population crash, or without having so many negative consequences going on the planet that our population isn't viable, or we have population crashes, we have more wars if we need any more, over water and over food. So, I don't know, we shall see. Here is our graph. This is called a J-shaped curve right now because it is showing exponential growth of the human population. So you can see it was flatlined for a very, very long time. And then it started to really kick off. And where that kicker really is like right about here. Boom! And it just exploded. So the question you have to ask yourself is, what took place during this time, which would equate to about the 1960s, that really sent this population skyrocketing? So what is it? Very good. It was the development of antibiotics during the 1960s that really gave us the advantage that we needed over bacteria, and helped cure so many diseases that were killing millions and millions of people. Now, the invention of antibiotics led to just drug development in general, and more funding for it, which then led to vaccines that we never had before, and all these things, just better medicine in general throughout the last six decades, has really helped extend human life, end premature deaths, and reduce infant mortality, which is something big we'll talk about later. So cultural carrying capacity is basically, we want everybody across the world. It'd be nice if everyone could live good quality lives, be free, keep future generations in mind, not have to degrade the planet today, so that way leaving nothing for future generations. And that's what this cultural carrying capacity is all about. And what we have to ask ourselves again is, how many people can we support? Can we support? So 7.2, what do you think the carrying capacity of the planet is for humans? Think about it. Don't Google it. Put your cell phone down. Don't Google it. Okay, so yes, it is about anywhere from 10 to 12 billion, they're estimating. 10 to 12 billion. That's crazy. It's a lot of people. All right, so what factors influence the size of the human population? Ability to expand to new habitats. We as humans are great at this. I think you could say maybe insects are better able to do this than humans. But other than that, we've got this under control. Modern agriculture feeds more and more people per unit of land. Every single year we're able to feed more people per unit of land, which may sound great, but at the same time it's a double-edged sword. And what I mean by that is, if you make, right now we have 7.2 billion people, and I'm sure we're probably making enough food to feed 7.7 billion. Because of that, it is a certainty that in the future we're going to have 7.7 billion. Once we have 7.7 billion, we'll make enough to feed 8.2. And it'll be a certainty that one day we'll have 8.2 billion. And this will continue and will continue until we've stripped out the resources on the planet, and we can't sustain anyone any longer. And of course, increases in sanitation, medicine, have reduced death rates. So another way of looking at this is population calculation. Let's see here. Okay, so looking at our growth rates. The basic way to look at your growth is, well, you take all the people who are born in an area, subtract away all the people that die, and that gives you your growth rate. All right? And that can also be used to calculate your annual increase. Same thing, birth minus death, and then you're going to divide it by 1,000. Why 1,000? Because usually when you do these problems on the AP test, and when you read this information and stats on, because you can go to any county or city and look up information about birth and death rates for that area. And usually the information is given to you per 1,000 people. So what that means is there are, in 2013, there were 5 deaths for every 1,000 people living in Seminole County. Something like that. So that's where that number comes from. And it does not have to stay 1,000. It can be any number, but they have to stipulate it in the writing or in the problem. But it's typically 1,000. And then you multiply it by 100 because you're looking for the percent increase, okay? Now we're going to take the same formula and go a step further with it, and we're going to add in more migration. Because it's not just births to add to a population in an area, it's also people coming in, immigration. It's not just deaths to take away, there's also immigration, which is taking away from population, right? Immigration, exiting. So if you group them together, your growth rate is really the birth rate plus the immigration minus the death rate plus immigration. And again, add that and make that into a formula. Now we can get more specific with our percent annual increase formula and say birth plus immigration minus death plus immigration over 1,000 times it by 100 to turn it into a percent. That gives us our annual increase.
Good afternoon, students, teachers, and staff.
It's now 3 o'clock and Hagerty High School is closed for the day.
If you're remaining on campus, you need to be under the direct supervision of a teacher, coach, or sponsor. All other students, please exit campus at this time. Thank you. Have a great afternoon. And as always, go Huskies.
Sorry about that. Okay, so these are the top 5 countries, the most populous countries on the planet. There's 2 columns because this is what's represented in your book, but it's old data. And this is current data right now. Maybe you're surprised to learn that the United States is the 3rd most populous country in the world. We are, but we also have a tremendous amount of land mass for those 318 million people. So, despite being the 3rd most populous, per capita we have almost more land per person than any other country in the world. And you can see since 2008, Brazil and Indonesia have actually flipped places. Interesting. I know. These 2 numbers, though, are referenced a lot. China being 1.3, I would always probably round it to 1.4 billion, and India being 1.3 billion. But I throw those numbers out a lot in classes we're talking about this because they have such ginormous populations. So now we're going to look at calculating crude birth and death rates. So the crude birth rate is the number of live births per X amount of people in the population in a year. Again, that would be, this X means 1,000 if it's given to you per 1,000 people. It could mean 10,000 if the problem says per 10,000 people in an area. And CDR is crude death rates, the number of deaths per X amount of people in a population in a year. For example, the lovely town of Pullerville experienced 234 births and 14 deaths for every 1,000 people in a town during 2012. What was the crude birth rate and crude death rate? So, we can do the following. We can take the crude birth rate, it's 234 over 1,000, alright? And in a problem, if it asks for the crude birth rate, you could leave it as that. You could also just leave it in decimal form, 0.234, alright? Or you can figure out this 234, it's what percent of 1,000, right? So 23.4% of that population is being born, right? And same thing for death rate. 14 over 1,000, you can leave it as that on a problem. You can write it as 0.014, or times 100 equals 1.4%. Now we're going to take this and throw all this information into the percent annual increase formula. So in the crappy rundown town of Mr. Pullerville, for every 1,000 people living in the area, the town experienced 47 births, 23 deaths, 22 immigrants, and 14 immigrants. What is the percent annual growth for this stupid place? Take a minute before I continue and try and put all this information together into that percent annual increase formula. There's a formula if you forgot it. It's white, and I'm sure you probably can't see it on this in your screen right now. That's birth plus immigration minus death plus immigration over 1,000 because it's given to you for every 1,000 here, and then multiplied by 100 because we're asking for the percent annual growth rate. 47 plus 22. From that you subtract 23 plus 14, right? This is birth and immigration minus death plus immigration divided by 1,000, and you multiply by 100, and you get a percent annual increase of 3.2%. Okay? The last one we're going to cover is the population calculations. Now, this is a statistical formula to calculate doubling time. Oh, goodness me.
Mr. DaCosta, please call extension 50700. Mr. DaCosta, please call extension 50700.
Okay, so like I said, it's a statistical equation. I had a stat teacher 3 years ago here at Hagerty explain to me why they arrived at the number 70, and she explained it to me, and I had no idea what she was saying. So, just know that the doubling time formula will always use the number 70. Always. Always. Okay? And this is the one time where we do math in class where you will leave the percent as a percent. So if you take 70 and you divide it by the annual growth rate for an area, you will get how long it takes for that population to double, right? So 70 divided by 2, if that's the area's growth rate, that population will double in 35 years. So for example, I'm going to lie to you and tell you that the population of Oviedo is 1 million. Nowhere close to that, but it is. I'm going to say that. So the population of Oviedo is 1 million people. The annual growth rate is 2%. What, or how long will it take for the town of Oviedo to move from 1 million to 2 million people? 70 divided by 2 gives you 35. So it's a 35-year doubling time to go from 1 million to 2 million, okay? Now, most of the time, like I said before, this is the only time we're going to leave that number in percentage. Because usually, if you're given a number and it's in a percent form, like say 5 times 25%, you can't multiply 5 by 25% because 25% is not a real number. So you have to do 5 times 0.25, all right? That is the real math problem right there. But here, you leave this 2% as 2. It's a special formula. It's the only time we're going to do it, okay? Anything else? Alright, nope, we're going to stop right there. Thank you guys for viewing this video. But before I let you go, oh, you know what? You didn't see a little drawing that I did. Hold on a second. When I was writing over there, it was this. Normally, if we have 5 times 25%, that is not a real number. You must do 5 times 0.25, because 25% is 0.25, okay? That's the real number. That's how you multiply it, except when you're in the rule of 70. Before this video was created, we said that the world's population, the last 3 digits were 713870. Let's go take a look and see what it is now. On our world clock, it is 716470. 716470, the last 6 digits. So we'll just go ahead and round up and say that during this presentation, almost 3,000 people were added to the world's population. Crazy!